exports the most potatoes is Belgium.
Belgium exports the most potatoes? How in the world do you know that? I love that. Did you just like randomly find that somewhere?
I really like potatoes.
You really like potatoes? I love that. I love that. Does anyone else have a fun fact?
There's actually a prehistoric crocodile named the Sarcophagus that has a bite force of about 18,000 pounds.
Oh, good Lord. That's more than a hippo. Oh, my goodness. That's crazy.
Pretty dangerous.
Pretty dangerous. My fun fact I learned from another class is that horses have less number of bones than humans. So they only have 205 bones and we have 206. So they have more bones by mass, but if you count them, we have more. So that I found very interesting.
If
Loved
you
that.
check out my background, you can see that the estimated size of a Sarcophagus is pretty large.
That's awesome. I love that. I love that you put the background up so everybody could see it. That's fantastic. Okay.
Yes.
So now let's do some chemistry things, okay? Chemistry things. So I had a question up here. Notice I say you'll need a periodic table today. It will help you. Calculator is also helpful. So if you haven't pulled that out, pull that out. In your Unit 2 notes, please have them in front of you while we go along. And my goal is to do like last class, and I want to call on every single person. So I'm very excited. We're going to be doing some math stuff today, and it's going to be great. Remember that today's hard things are tomorrow's easy things. So already there's some things that should be easier to you than when we first saw them. They're on the screen, so I'm going to call on some people to answer some questions. First up, Sangeet, you are lucky number 1. Sangeet, can you tell me the difference between an isotope and an ion, the best of your ability with all of the confidence I know you can have?
Okay, so an isotope is a change in the number of neurons, and an ion is a change in the number of electrons.
Yes, you said neurons, so I'm going to assume you meant neutrons, which is very close. So neurons are in your body, right? Neutrons are in the atom. That is very, very correct. And on the first try, you were the first person to get it the whole way on the first try. So congrats to you on the confidence. So the isotope is when you have the same number of protons, right? Different number of neutrons, which is what you said, changing neutrons. Now remember that things can have multiple isotopes. When we had carbon last week, we had 14, 13, and 12 as this number at the top, which I'm not going to say the name of because that's a question coming up next, okay? So, and you said that the ion, for those of you that missed it, that the ion here is when you have the same number of protons and a different number of electrons, which affects the charge, right? They are charged. So, next person, thank you, Sangeet. That was wonderful, and your confidence was the bestest. SD, why do both isotopes and ions have the same number of protons?
Because, I don't know if this is right, but because they have the same, or they always keep the same atomic, no, because that doesn't make sense.
Yes, no, well, it's close. So the atomic number is the number of protons, right? So that's wonderful that you remembered that. Fantastic. They have to stay the same way. If that's the atomic number, what does that mean?
It means that's the number of protons and only possibly electrons.
Yes, and only possibly electrons. I love the way that you said that. And it's the identity of the atom. The atomic number is what we organized everything by. This does not change. If we change the number of protons, we change what element we are, okay? And that's like, it would be like us spontaneously changing our DNA. We can't do that. We know that all of these carbons have 6 protons, right? Because it is carbon. Only carbon has 6 protons. It is what identifies the type of atom on the periodic table. Love that. Thank you, Esty, and thank you for having confidence. Okay, Maheen, you're next. This next one's kind of tricky, so I'm giving you a trickier one, okay? Atomic mass, relative atomic mass, and mass number. How do you differentiate these 3 types of masses?
Mass number is protons plus neutrons.
Okay.
Atomic mass is the weighted average of all the isotopes, I think. I'm not exactly sure what relative atomic mass is.
You are super close and they are completely related. They just have a small, tiny difference. So the mass numbers are protons plus neutrons. Bonus question. So Maheen, you were right. And I'm just going to redefine it a little bit more for what the word relative means. But I'm going to ask a real quick question first with someone else. Okay, Faisal, what is the mass number? Where's the mass number in this notation?
So the mass number is on the top. It's that 14. It's the protons
Ooh,
plus the neutrons.
Yes, it is at 14. This is the mass number, right? Love it, okay? So atomic mass, this first one, is the average masses of a single sample. So if I were to pick like this classroom as a sample and you were all atoms, okay? And I averaged how many females to males there were, that would be my atomic mass without the relative, okay? So that would be like taking a scoop of carbon sample and sampling what's exactly in front of me. Now, the relative atomic mass is the one that's on the periodic table. It's taking into account all naturally occurring isotopes in the universe that we are aware of, okay? So the relative atomic mass is everything that's on the periodic table. So I'm going to erase the rest of the ink. Does anyone else need the ink on the side still? Because I'm going to erase it so I can write something else. Actually, no, I don't have to. Well, yeah, I want to give you all a second if you're writing. Okay. No one said they needed it, so I'm going to erase. Okay, so the relative atomic mass, this is on the periodic table. Okay, periodic table. That's what the word relative, it's relative to everything in the universe. Everything, right? I'm writing really fast and it's messy, but it's everything in the universe. This one is just for a sample. Okay? Any questions on that?
What could you write down as a definition for atomic mass? Because
atomic mass is the weighted average of the masses of a specific sample of element, okay? Type of atom. Of a specific sample of isotopes is something else you could say. So it is the weighted average, and we're gonna do that in a second. And you've done this in math before, just so you know, like from yesteryear when I taught math and science at the same time. It's in the 7th and 8th grade math teaks for weighted averages. So you have seen them if you were in Texas in 7th and 8th grade. That does not mean you remember exactly what it is, but you should feel confident that you've at least seen it before. So when I start saying it, it might seem a little familiar, and that's a good thing, okay? So this shouldn't be completely novel if you were in the state of Texas in 7th and 8th grade, okay? So let us go to Canvas. I'm gonna show you exactly where to go, okay? You're going to go into Canvas. You have these course modules here, these beautifully titled course modules. You know exactly when your due dates are, right? So you don't end up with those late grades. Some of you guys got an email today about some things that need to now be turned in for a maximum of a 70, and that is okay. We are learning from that mistake, okay? We're going to scroll all the way down to the bottom to where it says warm-ups. That is what I click to get this to open up, and I'm just going to pull this over. Okay, so when you open warm-ups, it should look like this. Warm-up 2.3, this is where you're at. Okay, we're going to start using these warm-ups in the bottom more often. So if you want to print these out ahead of time, then you like to write on paper, that's something that you can do as well. Okay, for the I see a question in the chat that I missed. I'm going to go back and answer that really quick. So the relative atomic mass will be the number of decimals on the periodic table in your packet. So when you have your chemistry reference booklet, we're going to use those atomic masses with those decimal points during your examinations, okay? That's the one we're using. You will see other periodic tables online that have lots of other different numbers of decimal places. It's just whether it's more or less accurate. I want you to use the one from your reference packet for the purposes of this class, okay? That way everybody's using the same one. Does that answer the question? Okay, and reminder, tutoring today starts at 3:30 and you have to log in by 4:25. If you log in by 4:25 into that Zoom link, I will stay as long as you need me to. This is one of the last chances to go over your Unit 1 retake to do the retake assignment to get to the retake before Friday so you can change that Unit 1 grade if you were not passing. So there are some of you in here who have already done all of their requirements and retook it, and I'll be updating that grade. So thank you. If you would like to update your grade as well, it is possible. There are people here who did it. Okay, so we're gonna start right here with barium. This question says, barium has 7 naturally occurring isotopes. So when I say the words naturally occurring, what does that mean? Okay, I'm gonna say your name wrong again. I think you went by something else. So, Jimin, I said that really bad. I know. I apologize.
It's Jimin. It's
Jimin.
fine.
Okay.
Yeah.
So, what does naturally occurring mean, sweetheart?
Natural. It doesn't have charge.
So naturally occurring isotopes, so we're assuming it's not dealing with charge, it's dealing with mass, good. And the words naturally occurring told you what? I think I missed that if you said it. Or if you
No,
were not sure, that is okay too.
Yeah, I'm not sure.
Okay, well, let another person help you out then. And thank you for validating my employment today. Remember, if you know everything I'm saying before I say it, I do not have a job. This is my job to help you. Your wrong answers are just as important, if not more so, than your right ones. And saying I don't know is empowering. So say it with confidence. Victoria.
I also do not know.
You also do not know. So when I say word natural, what does it sound like?
Like there's nothing affecting it. It's just there's no change.
It's existing in the earth naturally, right? Like trees
Right.
are natural, but steel beams are not natural because they're man-made, right? So hold on, let me mute. I think someone's unmuted and doesn't realize it. That is okay. It happens. Hold on a second. There we go. So naturally occurring means it exists in the natural earth. So we're talking about relative atomic mass or atomic mass here. Relative atomic mass or atomic mass based on those words. Is that Samuel? You're Bob, right? If I remember right, do I remember you? All right. Go ahead, Bob. I think this is atomic mass or relative atomic mass. It says you were talking, but I am not hearing you. I am not sure why. Yes, it is relative atomic mass, and you knew that. Why? And I will narrate for the group. He said relative atomic mass, that is true. What gave you that piece of information? And thank you for being patient and typing it out. I know computer issues are always annoying. Yeah, the other isotopes being there, they're everything in the universe, right? This is everything in the world. So relative means it's a sample of everything and it will end up on the periodic table. So we know what our answer should be because we have a periodic table, but we are going to calculate it anyway. So next question, and this is a concept question. This is a concept question before we get into the math. So Saya Lynch, Saya. Oh, well, she just said she was about to go.
Never mind, I'm still here. I was just about to.
Okay, I just saw that in the chat. So do that and then go. Okay, so I have a quick question, okay? So we have masses ranging from 130 to 138. When I calculate the relative atomic mass, right, the average atomic mass, what number do I expect it to be closest to?
Like the percent or like what number?
My final answer, when I calculate the average atomic mass on the periodic table, do I expect it to be closer to 138 or 130?
Like in the middle, I would think.
So remember we were talking about, and yes, that's where, so almost everyone, nope, take it back. Every class period, that's what everyone has said is somewhere in the middle for the first time I asked. I want you to take a look at the percentages. So let me give you an analogy, okay? Say you had a Skittles bag, okay? And 40 of them were blue and 10 of them were red. You leave it in your cart and it all melts. What color do you expect those to be? Do you expect it to be a really blue purple or a really red purple?
A really blue purple.
Why is that?
Because there's more blue.
So take a look at that chart again, just for a second in your brain space. This is a weighted average. Not everything occurs equally, okay? So which number do you think it would be closest to, 138 or 130, and why?
130.
So 130, we have 0.1% of our sample. 138, we have 70% of our sample.
Oh, then 138.
Right. So when we're doing these problems, you can check your work just by logic. You can go, okay, most of my stuff is 137, 138. So if my answer isn't close to 138, I did something wrong. If I get 126, I need to go back and look at something because something didn't go right. I didn't type in my calculator right. I didn't do the percentages right. Something is off. Likewise, if you got like 146, you're like, man, there isn't even a 146 on here. How the heck is that an answer? So use logic to check your answers because that's what science is. It's the application of those mathematical principles. So you can use your logic in that big brain space to do that. And thank you, Saya, for playing along. Go do your thing and come right back, okay?
Okay.
So, and thank you. I appreciate it. So, percent abundance. These are percentages, okay? We're going to do a brain blast to math class. Kai, what do we have to do with any percentage before we do anything with it mathematically? What do we have to do? Can we use it as is, or do we have to do something to it?
You have to convert it into a decimal.
Yes, we have to convert this into a decimal to use it. This is why, okay? So if you have a quiz, right, and you get a, hold on, select the draw tool. If you got a 4 out of 5 on your quiz and I divided that in my calculator and I saw a 0.8 and I put in the grade book in that little square 0.8 out of 100, would you be very happy? No, you'd be like, girl, I'll tell you what, my mom's gonna kill me and it's your fault. We gotta fight, right? No, that's not what you put. You would expect me to multiply that by 100% and you would want me to put 80 in the grade book so your mama would not kill you, right? Does that make sense? So the same is true, right? You didn't get 80 points. You got 0.8 of what was available. That was the actual math for it. So when we're using percentages, I'm going to erase that because it's not relevant and we need the space. So when we're using percentages, we have to convert them first. So Kai, thank you. How is next person? Charles, how do we convert the decimals? What are we doing to it right here? What mathematically are we doing?
So if I'm being completely honest, my brother called me.
I love
asked,
the honesty.
He asked if I can make him a grilled cheese.
So you were gone.
Yeah,
So
I'm not totally with it.
Okay, thank you for your honesty. I appreciate that. That is going to be my funny moment for the day. So 0.106 is a percentage like this, okay, with a percent. Pretend all of these have a percent sign. When we see percent abundance and you start seeing whole numbers, all of them are a percent, okay? So my question was, what mathematically do I have to do to convert this to a decimal?
Divide it by 100.
We divide by 100, which moves it 2 decimal places to the left. So I'd have 0.00106. What would be that next one, Charles? I'm gonna make you
0.00101.
Yep, and we would keep going down like that, moving it 2 decimal places to the left, or you could just divide by 100 in your calculator if you are not confident in your ability to do it on your own. I hope you get that confidence because I'm sure you are capable of doing it and you should practice. But if you're not confident yet, that is okay. Okay. And this last one. So we had to do that first. So when we're doing math, don't use this. Okay, don't use this. We want to use the decimals. Scale of 1 to 10 in the chat, how we're tracking so far. Give me some feedback. Remember, you are the reason I'm here. Without you, I don't have a job, so I got to know what's in your brain space, and I do not want to be a mind reader, okay? Only thing I'm upset about is that I didn't get a grilled cheese, because now I really want one. Some tomato soup. Oh, so good. It's like childhood all over again. Okay, Relative atomic mass is the, so I have a question in the chat, is the weighted average, meaning that we are weighting how much something affects it. This is just like when you calculate your grade in this class, okay? Tests mean more to your grade than quizzes do because tests are more important, right? So this is the amount it affects or the amount it's present, and that mathematically will affect the actual weight. So the reason we have relative atomic mass is when we're doing calculations, which we are going to do very soon, okay? In the next couple of classes, we're going to be calculating with this number, and it's going to be very important. We are assuming that the sample in front of us is the same as the universal sample because it will be very close to that. So this is what we need to use to do the rest of chemistry. So we don't want to say the mass is 130 and have our math be really off when the average is really closer to 137 or 138. Does that make sense? So it exists so we can make assumptions. Again, if you're a perfectionist, chemistry is not the subject for you. I mean, I'm a perfectionist, but I made it my subject. So you have to be okay with the fact there's always going to be a margin of error. Always, 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 because you are not perfect and things are not perfectly pure, and pure is rare, okay? So that is why this exists. When we're calculating relative atomic mass, I'm going to zoom out a little bit. There is a formula that we follow. You do not have to memorize it necessarily. When we're doing the average atomic mass, the way we do it is we say that the average atomic mass, okay, that's what we're calculating for, is equal to the first mass times the percent, right, abundance, plus the second mass times the second percent abundance, plus, and we continue all the way through until we get to that last mass times the last percent abundance, and that's going to be equal to this. So it's mass times percent plus, mass times percent plus, mass times percent plus, mass times percent plus, over and over and over until you get to the end of your sample. If you only have 2 isotopes, you do it twice. If you have 7 isotopes, you're going to do it 7 times. So if you want to write this really nice, you could say mass times percent plus, mass times percent plus, mass times percent plus, all the way down. And then you're going to put that in your calculator. So I want you guys to try to practice putting this in your calculator right now. The reason I want you to practice is because calculators are what? What do I say calculators are? Anybody?
Dumb.
Calculators are dumb. They're so stupid. They're ridiculous, right? They only do exactly what you type in. So for some reason you type it in wrong, even if you did all of this beautiful math work on your paper, it's not going to know, and it's going to make you get not points in Canvas, right? Canvas is already tricky enough. We don't need to make it trickier with a dumb calculator. So let's practice the calculator skill for me. Please type it in the way you would on your exam, so that way I know that you have it. I want to make sure you get all those things out now. And your answer should match what the rest of the class gets. So if someone wants to throw it in the chat privately for me, just because if you want to throw it in the chat privately so you can see your answer before I show you, that would really help me gauge your understanding. And I would appreciate you forever and ever. I mean, I already do, but it would just be a little bit more each time. It's wonderful. Okay, anyone want to throw it in the chat? Throw me the answer in the chat whenever you get it. I am patient. We are not in necessarily a hurry. I want to make sure you get this right. Anyone throws it in the chat would be super helpful as soon as you're done. Now, if you're getting numbers, I see some people got numbers that are higher than 138. Remember, check what you typed in the calculator. Make sure you did the decimal points right. If you did this correctly, In your calculator, you should have gotten 137.42. Now here we said round to the hundredths place. That is why we rounded to the 2 here. And the unit is what? The unit is what? Let me click on somebody, random names. Dia, what is the unit here?
AMU.
Yes, atomic mass unit. Next week, you will find out that, or later this week, atomic mass unit is the same as grams per mole. These are the same thing. Okay, these are like synonyms. They mean the same thing. I just want you to physically see it before we start doing it. So it's not completely new. But AMU is what you use for now. Just know that you can see it's also grams per mole. Okay, 137.42. Now, question of the day. Okay, Wajia, is this what we expected to see? 137.42? And remind me why we expected to see it.
Yeah, because the biggest isotope is 138.
Yeah, so we can't be above 138 and we can't be exactly 138. This is where my favorite fun fact of the day comes in. Are you ready? Okay, so this can't be 138 even if it's the most, because things that are below 138 exist, right? So the average number of arms of a human being is less than 2 for the universe, right? Because there's people that exist with only 1 or no arms. Therefore, the average number of arms on a human is less than 2. Isn't that funny? That just like makes, I think it's funny. And maybe none of you think it's funny, but I'm like, oh, less than 2, it's weird. Anyway, same thing with masses. It has to be between, it can't be above. Okay, so I want you guys to try this one. You were gonna try it on your own using the same steps. Don't forget step 1, right? Remember why you would be mad if I put in your grade wrong. Don't forget step 1. You're gonna try to calculate it, and when you've got the answer, throw it in the chat for me privately, okay? Throw it in the chat for me privately when you have the answer. I am patient, we are not in a hurry. I'm gonna give you just a minute to do that, and I'm going to drink my water so that my mouth isn't so dry. Okay, I'm seeing some answers come in. Oh, I'm so excited. Remember, you're also trying to identify the element. Don't forget that part. One of you guys did it and they did amazing. Alrighty. Okay, I'm gonna start calling on people. It's gonna be super fun. So Celine, what was the first step? What was the first step?
You convert the percent abundance to a decimal.
Can you do
Like,
that
you
for me?
divide
Run
it
down
by
the numbers you
100.
got. Yeah, you divide by 100. Run down the numbers you got for me.
0.0185, 0.0251, 0.88450, 0.11114.
Yep, and this is when we divided by 100. So we're no longer using these. Perfect. Thank you so much. I'm going to call on someone else now. Thank you for contributing and thank you for being confident. I love it. Okay, Sneha. What is the next step? Sneha, go ahead.
Oh, then you have to multiply the mass by the decimal for each thing.
Yes, and when you did that, what did you, and then what do you do between them? You multiplied and then?
You add.
Yep, you add each individual one. So when you did that, what number did you get?
140.12 is the rounded.
And what's the unit for that? Because we do not let our the numbers go out naked, right? We always dress them.
AMU.
Yes, AMU. Does anyone remember what I said that also could be called, just as a bonus question? That we're going to be seeing later this week and next week?
G/mol.
Yeah, grams per mole, G/mol. And I'm just showing you so it's not new next time, but just know that those are the same, okay? So 140.12 AMU. Now, if you already told me in the chat which element this was, go ahead and mute yourself, stay muted, okay? Because everyone who put it in the chat, most everyone who put it in the chat, I only see one or two that are off. Can someone be brave and tell me that they do not know how to identify the element so I can take them through some questions? Now, remember, when you're doing this, your wrong answers or not knowing is much more valuable to the class than knowing, because it helps us highlight patterns of thought and teach patterns of thought. So does someone want to be brave with me and go down the rabbit hole? I will love you forever.
I have no idea how to do
Izzy!
it.
Thank you. Oh my God, guess what? Guess what you're gonna get when you show up to campus? Because you were brave and you volunteer, you will get one of the cool stickers, okay? You have earned a graffiti sticker with your bravery. So these are the cool stickers too. They're not like little ones. They're like big ones that like go on your water bottle. They're like big ones, okay? So thank you. I appreciate you, Izzy. Okay, so first, when I say relative atomic mass, what are you supposed to think of? Which thing?
The periodic table.
Awesome. So what all information is on the periodic table?
The element and the atomic number and the atomic mass, or
So
the
you have
mass.
a symbol here, right? You have the atomic number. Remind me what the atomic number is.
The
Number of what?
Number of protons.
Yes, and then what's this bottom number?
It's the mass number? Or
It's
is it
the relative atomic mass. Remember, mass number is the number of protons plus neutrons. It's not the same, but it's very confusing. A bunch of old dead white guys decided that this was not confusing, but it really is, okay? So we have relative atomic mass, okay? And isn't that what we calculated?
Yes.
Yeah, so what could we do?
So just search for the element by the mass?
Yes, that's perfect. That's exactly it. See, you went from not knowing to knowing. Thank you for being brave. And you get a sticker when you come back. Okay, so 140.12, if we look on the periodic table, is atomic number 58, and element CE, which is cerium. So thank you for playing along. Scale of 1 to 10. Who understands? Whose brain space feels better now? Anybody? 1 to 10. Good. See, this was hard like 10 minutes ago. And now y'all are all dropping these 10s and 9s in here like it's nobody's business. So y'all are already improving as a group. That's fabulous. Okay. If you're still a little lost, that is okay too. Remember, fish and trees, fish and trees. If this is your tree and you really want to climb it, I will help you. Just come to tutoring. Come to tutoring. Okay. Now this question is using this concept and it's the next step. So this is different. Okay. This is different. So what I'm going to ask you to do is I want you to spend 1 minute trying to set this up. Now, I expect for there to be a point where you go, and that's normal. Okay, I expect that. So if you feel that, don't feel dumb, stupid, feel like a student and feel like I'm the teacher. Okay, you're doing great. Try to set this up. 1 minute. We have 60 seconds on the clock. Okay, 60 seconds. Try to set this up. Thirty seconds left. Okay, I'm gonna start calling on people. Okay, Darshan. I think I said that wrong. It sounded wrong in my head. Why do I keep doing this?
It was right.
I was right. See, now I'm doubting me when I'm right. Goodness gracious. Okay, Darshan, how did you start? What did you do?
Okay, to be honest, I kind of looked at the notes.
That's cool. You can look at the notes, but where do you start? Where do you start?
Well, I said that the percentages have to equal 1 for 100%. So I said 1 equals x plus y. That was the first
Okay.
thing I did.
So you are on like step 4, and that's beautiful. Can we go to step 1? So what do we have to do first in every word problem ever? What do we have to do first? What's the first step of every word problem?
Highlight the important information.
Yep, know what the question is and highlight the important information. So why is that not working? Okay. We want to know the percent abundance of each isotope. So we have more than one answer. Okay. That's step 1. We need to find the percent abundance of each isotope. How many isotopes were there?
There were 2.
So there are 2 answers before you are done. Okay. That's the first thing. I'm going to start picking on other people. Well, I'm going to come back to you when we start doing the percentage stuff. Okay. I'm going to come back. So just be ready. Okay. Sonali, what other information could I put down?
The mass, or the mass of both of the isotopes.
Yeah, so we have 191 IR or iridium, right? And we have 193. Those are the 2 different isotopes we're dealing with. So if we set up a chart, like in the first problem, because that's what's comfortable for us, right? We would have the mass, and then we would have the percent abundance, right?
Yes.
Okay, so the mass is what for each one?
190.96 AMU.
Okay.
And 192.96 AMU.
Yes, love it. I put the unit up here, so it applies to everything underneath. Okay, now coming back to you, told you it was coming. Now tell us what you were saying about percent abundance.
Well, I said for the first one, I labeled it as X because we don't know what it is. And the second one, I labeled it as Y because we also don't know what it is. And then I said both have to equal 1 because they're percentages.
Right. So I know that's what you said in the notes. That is one method. I want to show you guys a method using your logic that's the exact scheme, but takes out the Y part. So for those of you that struggle with systems of equations, I'm going to teach you something that will help you with it. What you said is absolutely correct. Okay. Yes. X plus Y equals 100. And then you go from there. This is the exact same thing, but without the Y. Okay. We're going to go through and I'm going to tell you why. Okay. So You said you looked at the notes because you weren't sure. I'm going to call on someone else. So know that your notes has an option here. But Eden, okay, Eden, if I told you that this class was 50% male and 20% female, does that sound correct to you?
No,
Why not?
because it doesn't add up to 100%.
Yeah, so if you had a class, right, 50% plus 20% is only 70%. That means 30% is missing and therefore it's not right, okay? Another way I could have said that, because when we do math with percentages, we divide by 100 first, right? Is that 0.5 plus 0.2 equals 0.7? That's still not 1, just like this was not 100, right? So what do we know these two numbers have to add to?
100.
Had to 100%, which is the same as what in decimals? So these added to 100, right? 100%. What do these add to?
1.
Yes, so this is equal to 100. This is equal to 1. There we go. So if it has to equal 1, say I told you that this was 0.3. What would you know this was? If this is 0.3, hypothetically, I'm not saying it is. Let's pretend that this is 0.3. What would this one have to be?
0.7.
How did you do that in your head?
Because it has to add up to 1.
So you did what in your head? What math?
Subtraction.
Yes, there we go. I was trying to get you to say the word. It's the math teacher in me. Addition and subtraction are really the same thing, right? So we know it was 1 minus whatever this was. That's why in the notes, when they say x plus y is equal to 100, subtract the y, solve for x, replug it back in, that's a bunch of math steps you can skip if you know that both of these have to add to 1. So this one's x, this one's 1 minus x. Does that make sense? Because I know I am doing it slightly different than the notes, but I am not Mr. Harridum, and I want to show you another method, okay? Any questions on that? All right. Next person. Thank you, Eden, for letting me pick on you. I know it was a long time. Okay, Jonavi, did I say that right this time?
Yeah, you did.
Yes. Eventually. It just takes like 5 weeks, guys. It's cool. Okay. Jonavi, what's the next step, baby girl? What do I do next? Yeah, that's not feeling. Whatever you say it with confidence. Because even if you're wrong, you can be confidently like unsure. Be like, I don't know, but I'm going to say this because that's where my brain is going right now. And that tells me how you think and helps me help you. So confidence is key.
I'm not sure.
You're not sure. Okay. So what is this number that we were given? Do you know?
The atomic mass.
Where would I find this in your data booklet? In your reference packet? You'll hear me say data booklet because of IB. So just, it's a reference packet, okay? Where would you find this? Where do we find it here? Where do we find it here?
The periodic table.
Right, so that's our end solution. When we do mass times percent plus, mass times percent plus, mass times percent plus over and over and over, that's our answer. So I'm gonna ignore this question. So just pretend this isn't here because I want the white space. Okay, we'll go back to that in a second. That 192.2 is the end game. 192.22 AMU is equal to mass 1 times percent 1, right? Plus mass 2 times percent 2. That's what that's equal to. That's the answer in your head. Does that make sense?
Yeah.
Okay, beautiful. Thank you. I know that's scary when we don't know. Okay, Carter, you're up, man. You ready, Freddie?
Yep.
What do I do next? I know that my 192.22 is here. What do I do next?
So you need to put in your first mass.
I put in my first mass, which is here, okay? So I have 190.96 times, what do I put in?
1 minus x.
Yes. Now I want you guys to know that it would not matter which one you started as x, the other one 1 minus x, and it does not matter which one you start with. But I just happened to write it that way for, I don't know why, okay? But either way, it'll work out. Beautiful. What do I do next, Carter?
Next, you'll put in your 192.96.
Okay, times the x, right? Beautiful. That's where that came from. So these two went here. These two went here. Give me a scale to 1 to 10 of how you're tracking so far. Just because this is algebra, and I know as a former algebra teacher that this can get a little hairy in your brain space if you're not as confident. And that's okay. I just want to make sure you're very clear where I'm getting each number. Okay, good. We see everything from 5s to 10s. Beautiful. All right. Next step, the wheel is going to choose. Thank you, Carter, for letting me pick on you. Next step. I know we're going a little slower through all this, but that's because I really want you guys to get it. Milan, okay, Milan. What do I do next?
You have to distribute the in the parentheses and the 190.96.
Yes, we distribute. So when I do that, I get 190.96 minus 190.96x. And then I maintain the other ones, right? So we didn't do anything to anything else, so those will be the exact same. So I'll still have 192.22. That'll still be there. I'll still have the 192.96x. Beautiful. Thank you so much, Milan. Next step. Akshar, what's the next step?
You add up the x, the like terms, and then you subtract the 190.9.
You even used a math word? That just warmed my heart. Oh my goodness. You said like terms. Huh. Whew. Someone pays attention. Okay. So we're going to combine our like terms. Okay. When we have positive 192.96 and negative 190.96, that's the same as saying 192.96 minus 190.96. So since these decimal places are the same, that's going to leave us with a positive 2x. Okay, beautiful. Thank you so much. And I love that you said a math word. Oh, it was so pretty. Okay, 190.96. And this still stays the same. We haven't done anything with that yet. Okay, beautiful. What do I do now? And I'm going to ask someone else. I told you we're going to do lots of math today. Okay, Magana, what do I do now?
You subtract 190.96 from both sides.
Yes, and that leaves me with what? So these cancel. What does that leave me with?
1.26.
You get 1.26 is equal to 2x. And go ahead and tell me what that last step is.
You divide it by 2.
You have divide by 2 on both sides. So those cancel, you're left with x. So what do I get x is equal to?
0.63.
0.63. Oh, great, I'm done. Okay, guys, I'm done with my problem now. Yeah? Am I done?
You need to add the atomic mass.
Oh, why are we shaking our heads? Yes, we have one answer. What did we say we needed? Yes, for the atomic masses, right? What did we say we needed? 2 answers. So you could do all of this beautiful math, get all the way to the end, box your answer, and be like, whew, I'm done, and then not be done, right? So always when you go back, that's why that first step is so important. Always go back and check you answered the question being asked, right? If I asked you what your favorite dinner was and you said VW Beetle, that's not answering the question. I mean, it might be an answer to a question, right? It might be your least or most favorite car, who knows? But it has nothing to do with dinner, right? So we want to make sure we're answering everything we're asked. So if we want this, we know x is equal to 0. Well, what did we say? 0.63, okay? So what does this guy have to be equal to? Anybody?
Negative 0.63?
It won't be negative because we're talking about percent abundances, right? So when we say negative, that would be like opposite. Negative percents would mean that we ended up with less than we started with. So what we're talking about is we want to know how much is left over. So Esty, go ahead and try again. That was beautiful. And thank you for being confident. You were wrong answer. You know, I've had 3 people say that. You are not the only one. So thank you for being so confident and letting me highlight that to the group. That's very good. Okay. So if it's talking about what's left over, 1 minus 0.63, what would my answer be then, SD?
0.37.
Yes, which is the same as 37% and 63%. Okay, awesome. All right, let's see. The 1 minus x represents what's left in the universe. So if we're talking percentages, right? This is like saying, so when we say the 1 minus x, we're saying 100% minus the percent we know is the percent left. So that's what you just did, okay? So that 1 is just when we divide by 100. Percent in decimal equals percent in decimal left over. That's what that means. I saw that in the chat. I know that was really messy and scribbly, but hopefully it makes sense, okay? So we're just subtracting, say if we know it has to add to 100 or it has to add to 1, we're subtracting what we know to find what's left over. That's like saying, I had 10 apples, 2 of them were green, how many are red? 8, right? Because we subtracted from the total. All right, cool, and 1 is our total. So 37%, 63%. Last question, question of the day, $1 million question. Trisha. Okay. Does this answer make sense and why?
I think so.
I think so. Say that with some confidence and I'll let you say the rest. Say,
I think so.
yes. Why?
Well, they both add up to make 100%.
They both add up to make 100. Now remember what we did here with the logic part, right? Where we knew it was going to be heavier because there was more percentage there. Take a look at the percentages we calculated, 37 and 63. Does 192.2 make sense within that kind of thought?
Yeah, because it's closer.
Yeah, it's closer to the heavier one, right? It's slightly over half. It's closer to that 192. 192.96 is closer to 192.22. We know that's correct. Yes. So Sneha, I see that you asked that question in the chat. Yes, you can use a calculator to solve this if calculators are allowed on the exam. This is a system of equations. If you know how to do matrices and all of that stuff, I'm cool with it. I don't care how you do the math. I care that you understand the concept. That's why I've spent a lot of time today on, like, we didn't actually spend a lot of time on systems of equations. We did some algebra checks, so I know that you know how to distribute and things, because those are things that as a math teacher I saw students struggled with. But we spent most of our time today talking about why these are the answers and why they make sense. That is what I care about way more than how you put it in the calculator, as long as you get the correct answer. Does that make sense? Good? Okay, so lovely students, lovely students. Are there any last questions before I show you what you can do for the rest of the time? We're going to set you free for async. Any last questions on this paper before I move on? Okay. Oh, wait, I forgot that last question because I crossed it out. We did have one more question. I'm going to call somebody. See, I needed a second for my brain to work. Sometimes it takes that. All right, so Evangelina. Are you here, love? Look in the participants. Okay, let's go with Eva then, because you're right next to that and I see it. Eva. Yes, dear. You have the very last question of the day. Are you ready?
Yeah.
Is it better to use mass number or atomic mass, and why?
Would it be atomic mass?
It is, and I would love you to say that with confidence. You're going to say it again like you knew it all along. Are you ready? Go.
Yeah, atomic mass.
Yes, it is atomic mass. Why did you say that?
I don't know. It felt right.
Okay, can I give you a hint?
Yeah.
Okay. Remember those weird rounding rules we did? And when we had the test questions about measurement, what was that all about? It was called what? Starts with an S.
Significant figure?
Significant figures. And what do they tell other scientists?
Like the right number? That didn't make any sense.
It does. It tells you the right number of digits. It tells the right number of place values. It does make sense because I totally tracked. So you need to have that confidence word. Confidence, man. I'm going to start playing that song on your intro. We all are waiting in that room, okay? Have some confidence, okay? So yes, it's the number of place values you keep. So why is the number of place values you keep important?
Because it helps you find like the exact number, like
I'm looking for an A word. It's not precision, it's
accuracy.
yes. So you're communicating accuracy, right? More place values is better instruments and more accurate. So here our place value goes to the ones because we're counting. Here our place value goes 6 past the decimal. What kind of super whammadine balance is that, right? That's way more accurate. So it's a better number because it's more accurate. Okay? Thank you, Eva. I know that was painful, but you did great. And I love what you did. Okay? All right, guys. So I'm going to show you Canvas to show you exactly what you have left. Remember, we have these titles now, so you know exactly what's due. Okay? So today is the 15th of September. So I would come to our titles and find everything that said 15th of September. Okay? The video notes you should have already done. If you have not done them, don't tell me, don't break my heart, just do them now and maybe they'll make more sense, okay? So make sure you have those notes done because everything, the test, all of it is open note, right? So if you have your notes, you have more information that is directly related to your test that we made the test off of, okay? Second, you have activities. So you pick one of the average atomic mass activities. There's 3 options and you do QC 2.2. Now, yesterday we found there was an error on one of the questions. So if one of the questions is like, it won't accept the right answer, it has something to do with the number of electrons, neutrons, etc. If it won't accept the answer, I know about it already, but since other students already took it, I can't change it. So I am just going to grade by hand for that question. So I'm going to grade these by hand, which means the grades will be probably by Friday instead of today in Skyward. Okay, but I do know that yeah, you got an email. Oh, hate that. You got an email that was telling you that I understand that UIL poll is 8 a.m. Monday. Your grades will be updated and I will be through all the regrades and grades by then. So just know that I'm aware of that and I sent you an email about it. Okay? Good. If there is nothing else, go ahead and go do your things. Okay? You have these to do. You have these to do right here. Love you. Loved working with you guys today. Okay? You guys did a great job.
Thank you.
Thank you, guys. Okay, I see some stuff in the chat.
Miss Longley.
Yes, how may I help you?
So for the bead baggy activity, I accidentally submitted it to the entire wrong module.
Oh, you did the Barium lab one?
Yeah.
Yeah. Okay.
I accidentally started that one and then I realized, and then I did the bead lab and then I turned it into the Barium one. So then I had to return it into the bead baggy lab.
Okay, well then I won't count that late then because you did it on time. It's a technical glitch. I'll write a note. You're good. I got you, girl.
I think it was a personal error.
Yeah, well, Barium and bean are very close, and I said that when we were in meeting. I was like, oh, that's a little close for me. They're like, it's all right. I was like, okay, so you're good. I'll check your Barium lab and look at that. Okay.
Okay. Thank you.
No problem. All right. Any other questions?
Yeah, so when I was doing the beads in the bag quick check for the questions, it would not let me put the negative sign in. I think I emailed you about this.
Yes, I saw the email. I just hadn't had a chance. Like I said, I saw it, and so I'm glad that you stayed after. Yeah.
And then also for when I was scheduling the retake for my Unit 1 test, I saw that it said 15 minutes, but we get 45 minutes for because when I was scheduling it said my time slot was for 15 minutes in the testing center.
Yeah, no, you'll get to do your whole test. That's 15 minutes for them to open it up, set it up, and get you started because it's virtual, right?
Okay,
so that's 15 minutes they will engage with you. Yeah. You're good.
And then I can just finish it later.
Yep, that's perfect.
Okay. Thank you.
No problem.
I want to quick check in the biggie bag thingy, the bagging.
Yeah, I got you. I'm tracking.
So
the question that you said error on, so I couldn't find the right answer, so I just clicked the random one and I got it right. Will that be regraded too? Like, I don't know.
Well, if you get it right, if you submitted it right, all I can see is what you submitted. So, I mean, it'll be right, if that makes sense. Like I'm grading your submission, not like, I'm gonna look at that specific question. Does that make sense? So,
Oh,
yeah,
so
if you already got it right, you're fine. But we'll be looking, I'll
Mhm.
just look at that question. I'm either going to, depending on how it goes, I'm either going to give everybody the credit for it because it wasn't fair, or I gotta see, but I gotta actually get into grading it to see which way I'm gonna do it. Okay? I may just give everybody the credit because it was an unfair question, but if there were some people who were able to get it right, I may look at that differently. We'll look at it. I'll do what's most fair for the group. Okay? All right.